Hey guys, and welcome to the school station. Today's video is going to be about specific heat capacity. This is from the AQA GCSE Physics 91 paper from the unit Energy and Energy Resources. Today's video is going to be about specific heat capacity, what it is, and also its separate formula. I hope you guys enjoy and I hope that this helps you, and let's just get right into the video. So first of all, we have to talk about what is specific heat capacity. Specific heat capacity of a substance is the energy needed to raise the temperature of 1 kg of the substance by 1 degree Celsius. Let me just repeat that again for you guys because this may be a little bit hard for you to understand. Specific heat capacity of a substance is the energy needed to raise the temperature of 1 kg of the substance by 1 degree Celsius. So basically what this means is, for example, if you get a substance, like let's say copper, and you want to find the specific heat capacity of the copper, you basically have to calculate, if you want to find the specific heat capacity, it's basically calculating the energy needed to raise the temperature of the copper by 1 degree Celsius. So we only take 1 kg of copper, and you want to see how much energy is needed to raise the temperature of that copper by 1 degree Celsius. If it's 21 degrees Celsius already, we want to see how much energy it needs to actually raise it by 20 to 22 degrees. So therefore, this means that this is basically how you calculate specific heat capacity of a substance. You take 1 kg and you basically want to see how much energy you need to raise the temperature of that substance by 1 degree Celsius. So now that we've clarified what is specific heat capacity, I hope you guys have understood. Now we're going to actually go on to the rules about specific heat capacity. So there is actually 4 main rules about specific heat capacity. So there is actually a required lab practical for specific heat capacity. So especially if you're studying GCSE Triple Science, there is actually a specific lab practical you have to do for specific heat capacity, and that should be done in your class or in your lessons. The second rule is that more heat energy increases kinetic energy. So for example, let's say if we basically are heating up a pan, or a pan of water, or if we're just heating up a kettle of water, and when we're actually heating it up, we're giving it some heat energy, and as we're giving it heat energy, it's basically increasing kinetic energy, because if you're boiling water in a kettle, you will see that the water is basically bubbling, and this is because when you add heat energy, it basically increases kinetic energy. So the more heat energy there is, the more kinetic energy is also added to it. The third rule is that every object has a different heat capacity. So for example, if there is copper and zinc, they're both going to have different heat capacities, and you have to find a specific heat capacity by actually following the rule that I actually showed you guys earlier, which is specific heat capacity of a substance is the energy needed to raise the temperature of 1 kg of the substance by 1 degree Celsius. And last of all, we also have to know that an example of a heat capacity and what it is a storage heaters, because storage heaters have a high heat capacity, which means it allows them to store heat. So the higher the heat capacity, the more it will actually allow you to store heat. And storage heaters are really useful because obviously they have a high heat capacity, so it will allow them to store the heat. So now that we actually clarified what is specific heat capacity and also some rules and information you have to know about it, now we actually have to think about what temperature really depends on. So specific heat capacity is all about temperature and how much energy is needed to raise the temperature. So 3 things temperature depends on when a substance is heated is, number 1, the amount of energy supplied to it, number 2, the mass of the substance, and number 3, what the substance is. So basically, for example, you're going to see that obviously it takes a different amount of energy to raise the temperature of a copper than to raise the temperature of zinc. So it's going to be 2 different types of material, and this is 2 different substances. And obviously the number 1 thing is the amount of energy supplied to it. So obviously if you apply less energy to raise the temperature of copper than zinc, it's going to be different. Number 2 is the mass of the substance. If you take 1 kg of copper but 2 kg of zinc, then obviously that's also going to be different about how the temperature is going to be raised. And last of all, we also, what the substance is, obviously copper and zinc are both going to have different ways of heating, and its temperature is going to depend on what the substance is. So those are basically three things temperature depends on. And now we're actually going to go on to the specific heat capacity formula, which we obviously have to memorize. So the formula for specific heat capacity is E is equals to m times C times theta. So obviously E is the energy transferred in joules, and this is heat energy. So this is basically what you would call a heat energy formula, because before the equal sign, it's heat energy. So instead of calling this formula for specific heat capacity, you can just simply call it formula for heat energy, because it's not necessarily telling you specific heat capacity is equals to the rest of the equation. It's actually saying heat energy is equals to. So I would call, if you want to, you can also call this just the formula for heat energy. So heat energy is equals to M, which stands for mass, and that is the mass of the substances measured in kg. C is a specific heat capacity, and joules per kg per degrees Celsius, so joules per kg per degrees Celsius, and that is a specific heat capacity. And theta is the temperature change in degrees Celsius. Sometimes this can also be presented with a triangle and T, like over here, because this triangle actually is a Greek way of saying delta, and delta basically means change in, so that would be change in temperature. So delta T represents change in temperature, but sometimes it can also be represented as a theta. So those are two different ways of representing change in temperature, and obviously that is measured in degrees Celsius. So again, over here we have the formula for heat energy, but if you want to actually find out the specific heat capacity, what you would have to do is you have to cover this in this triangle, you have to cover this up, and what we would do is we would do heat energy divided by mass times change in temperature. So that's basically the formula for specific heat capacity, while this is the formula for heat energy. So that's basically how you would actually solve questions. And remember that sometimes they're not always going to exactly ask you for specific heat capacity. Sometimes they're going to ask you for the heat energy transferred. Sometimes they can even ask you for the mass. So again, you would have to cover the mass, and it would be heat energy divided by specific heat capacity times change in temperature. So you just have to really use this triangle accordingly. So now that we've actually found out about the formula, and now we can actually start solving questions involving specific heat capacity and heat energy. So the number one question we have is, how much thermal energy does a 2 kg steel block, so C is equals to 450 joules per kg per degree Celsius, lose when it cools from 300 degrees Celsius to 20 degrees Celsius? So first of all, what I would definitely advise you to do is to see what you have. So we have the mass, we have the specific heat capacity, and we also have the change in temperature. So since we actually know the formula and how this question has been set up, I want you guys to pause this video and try to actually answer this question yourself before continuing with the rest of the video. Alright guys, so I hope you guys have tried out this question. So here is the answer. So over here you guys can see that the answer is 252,000 joules, and the reason why is because first of all I started off by writing down the heat energy formula. E is equals to mc theta, and obviously we know that we're just going to use exactly how this formula is set up because they're asking for the heat energy, so this is we don't have to change this formula in any way. And then the mass is 2 kg, so we put 2 times 450 because it actually clearly says over here that C is equals to 450 joules per kg per degree Celsius, so we don't really have to do anything, we just put 450 in there, and then times 300 minus 20. Now the reason why is because it actually asks you for the change in temperature, and when it asks you for the change in temperature, it basically wants you to see the final temperature, the initial temperature minus the final temperature. So 300 degrees Celsius was the initial temperature. It was before the steel block was originally 300 degrees Celsius, but the final temperature was actually 20 degrees Celsius. So you have to do 300 minus 20, and then that's going to basically be 280. So 2 times 450 times 280. If you just type that into your calculator, you'll realize that it is 252,000 joules. So that's going to be an answer about how much thermal energy a 2 kg steel block needs when it loses when it cools from 300 degrees Celsius to 20 degrees Celsius with this specific heat capacity. So there you guys have it. This is basically an example of how to solve a question involving heat energy. I hope you guys have enjoyed this video and I hope that this has helped you. Just to go as an overview of what we have learned in this video. Number one, we learned what specific heat capacity means. Obviously, you guys can definitely write this down somewhere to make sure that you know what is specific heat capacity. Second thing we learned was the formula for specific heat capacity, which is E is equals to mass times specific heat capacity times theta. So that is actually this formula for heat energy, but obviously you can use this triangle over here and figure out the formula for specific heat capacity. And last of all, we also learned how to answer questions involving heat energy and specific heat capacity. So I really hope you guys enjoyed. Give it a thumbs up if you actually enjoyed this video, and I hope this helped you. Also subscribe down below if you want more videos from the school station, and I hope to see you guys very soon in my next video. Bye guys!